So here we have this example of like a real world juggler throwing balls. You can always imagine what this is looking like. And we want to get an equation for the height of the ball. We want to find the maximum height that the ball is going to reach. Maximum height refers to, as we know from our previous lessons, that vertex, the y value of that vertex. But before I can do that, I'm going to need to figure out what the equation looks like. So let's talk about the equation from the last video. Here's how I want you, when you guys see h parentheses t, here's what I want your brain to think. The height for any given time t. For any time you can think of, the height at time t is going to equal negative 16 t squared plus whatever that starting velocity is times t plus whatever the starting height is. And then these values are always going to be in our word problem somewhere. We'll be able to figure out what the value for this is and what the value for this is by reading the problem. So in this situation, we got the juggler tossing balls in the air. It leaves his hand 4 feet above the ground. So this is going to be equal to 4. I'm just going to plug that in for h sub 0. And has an initial velocity, upward velocity I should say, of 40 feet per second. So I'm going to change this into a 40. And then negative 16t squared is going to be just what it is because we're on Earth. That's where the 16 comes from. So this is the quadratic I'm dealing with. Now, if this is bothering you, keep in mind this is just the height at time t is like how high is it off the ground. It's that y value. So if you want to think about this as if it were a gigantic y, that's okay. Essentially, we're just getting this quadratic y equals negative 16 t squared plus 40t plus 4. And now we're being asked to find the maximum height, which we know is the y value of the vertex. This quadratic is in standard form, so if I want to find that vertex, I will have to bust out the opposite of b over 2a. I can look at this equation and know that the a value is negative 16, the b value is 40, the c value is 4, so the x value of the vertex is the opposite of b divided by 2 times a, which is going to be negative 40 divided by negative 32. And that's going to be a gross number, so I'm going to pause while I get my calculator. So that's going to be equal to 1.25. That's the x value for the vertex. But I need the y value of the vertex. So now I'm going to take this value, and to find the y value, what have we been doing all along? We take the x, we plug it in for t, or x, to find the y. So you might be noticing I'm saying x, but the equation has a t in it. I'm kind of using t and x interchangeably. You definitely can think of these t's as x's if it helps you, keep things consistent. But we call it t because it's related to time. So whatever. This is a value for t or for x, however you see it. We're going to plug it back into here, and so we'll figure out what negative 16 times 1.25 squared plus 40 times 1.25 plus 4 is. And again, I'm going to pause the video while I get my calculator out to figure out what this ends up being. Whoa, this juggler is really chucking these balls up in the air. It's going to be 29 feet. It's the maximum height of that ball. So I hope what I'm showing you guys is the only new step is to be able to read this problem and understand that we need to figure out what this value is and what this value is, and they'll be given to us within the problem. Our goal is to get some kind of quadratic, and then we'll answer questions about that quadratic. If the question's about the maximum height, we know it's the y value for the vertex, so we're going to use all those same skills we use when graphing to answer the question like this. I do want to point out the answer is this 29 feet, the y value of the vertex. So hopefully that makes sense. Let's try another example.